UN75MU6300. So the customer said about this TV, they hear a pop, and the TV show lines goes off. That's the last thing they see in the TV. After that, it won't turn on. All right, let's use the watt meter, and we plug the TV to it. So this is going to tell us if the TV take any power. This is help. Yep, it's zero, completely zero. Yeah, the TV is look like completely off. Of course, there's going to be no standby light because we already did the test over there. Telling us is the TV taking nothing. Usually take like 100 milliwatt for the standby. We can unplug the main board, like just in case if there is any short in the main board and that's blocking the standby. If we plug the TV, should have the backlight now. The amp meter is zero completely. All right, let's plug it and we check in this big capacitor. We should have between 160 to 300 watt in these big capacitors. What is the DC? Yeah, it's a zero completely. So these capacitors, they get fed from the rectifier bridge, these two here. And let's check the fuse. The fuse is open. That's explain everything. So the fuse is open. So the fuse is open, easy job. Let's change the fuse. It doesn't go like that. We need to check why the fuse is open. We need to be sure if there is anything cause the fuse to be open. So right here in the rectifier bridge, okay, we have a diode here. This diode is shorted as well. So let's check the board and test it. Alright, this is the power supply. So we know that as we test before, the fuse are open. These two rectifier bridge is connected. Yeah, the two rectifier bridge is connected on parallel, so they use them as a one. The first two MOSFETs, and we have this, I think these two MOSFETs for the step up. This is the coil for the step up, and this is the switching power supply. It's here to the transformer. So the first two MOSFETs, yeah, the first two MOSFET tested shorted, and all the pins test shorted, and that's bad. Because if the fuse didn't blow quick, that high voltage is gonna reach the oscillator or the switching IC. So this switching IC is sending like about 20 volt, around 20 volt to the gate of the MOSFET. But when the gate of the MOSFET is shorted with the source, it will send 120 volt in the pin of the 20 volt. You can see the difference, and that's may burn the switching IC. But hopefully the fuse burned before the high voltage reach the IC. So the other MOSFETs, this one's here, not tested okay. Oh, this is a diode. Yeah, this is a diode. So I'm going to take these two MOSFETs that tested shorted. That's what we start by. Yeah, this diode is just like a bridge diode. So it's connected between this MOSFET to this MOSFET. So you can see it is from this pin, and that's like it. Like that's the drain of the MOSFET. It's go to the diode, and it's go to the other drain. This is the source. No, this is the gates, and that's the sources. Alright, let's test the diode now after we remove the MOSFETs. Yep, you just read one side. That's good. That's a diode. Yeah, this is. So it's still any short in the B capacitor. No, it's not a short anymore. Yeah, if we are lucky, it's going to be just these two MOSFETs. If not, we are going to need to replace the switching IC. This one here. And sometime maybe a little component, diodes, or the transistor, they go bad. And I think we can check for the oscillator, see if we can get any wave. Alright, let's jump the fuse. Just to test the board. Yeah, after we're done, we're gonna replace that fuse. And let's put a little solder ball over there to find something where the oscilloscope is going to catch. So the ground of the oscilloscope is going to connect to the ground of the high side, not to the ground of the low side, the secondary side. So to check where is the ground for the high side, you can look at the capacitor, the negative side of the capacitor. So that's the negative side of the capacitor. And so here, this is the negative side to the capacitor to this point. Yep, there is a, so that's the point where we are gonna connect the oscilloscope. So the board, I'm gonna connect it to the power now, just in case if anything not blown. So yeah, I think we can check at the moment it should be like the rectifier bridge all the way to the capacitors. We should have some voltage. Yeah, it should be a DC. Yeah, we have 156. That's good. At the same, we can check the voltage in the gauge of the MOSFETs. So that's the gauge of the MOSFET. So we have 8 volt in the gauge of the MOSFET. Likely the switching IC is still good, but we still need to check it with the oscilloscope. I see something over there like a wave. Let's try the other side. Yeah, the other side we have the wave. You see it? Yeah, you can see the wave, it's came and go. Cause the, all right, let me disconnect the power supply. So the wave, it's came, it's go. Because this IC now, we just working with the voltage start. So when it's get to the voltage start, it do the wave, then cycle. And because the voltage start is just for the first wave. It's not for the IC to work all the way. Then the IC is going to get the voltage from the transformer. The VCC is going to be coming from the transformer, not from the voltage start. But that's a good sign. We have a wave. The IC is still good so far. So yeah, I find these two MOSFETs in this donor board. And this is the closest one that I can come with, is 6TR190Q. And if we go to the, okay, that's the original one, is a 18N50, and you can see it's a 500 volt 18M and 0.270 ohm. The one that I have is this one here. So this one is a 650 volt and 20 amp and 0.19 ohm. And you can see the source, the drain, the diode is going from the source to the drain. It's kind of the same as this one, from the source to the drain. This is an N MOSFET. This is an N channel MOSFET. Alright, this is 500 volt. This MOSFET is more powerful than the other one, so it's like we are upgrading it. Alright, let's test the MOSFET. Yeah, usually you have blowed fuse. Always check the first two MOSFET. We're going to check this MOSFET with the transistor tester. Just we want to be sure. Yeah, it's an N channel and 0.4 ohm, exactly as it showed. So this one is good. Same thing, this one 0.4 and this is an N channel. This is the one that I put rechargeable battery, and I put a USB-C port. So still working good. The battery hold a good charge. Like I don't charge it like 2 months or more. All right, let's see. I'm gonna leave the jumper over there. And let's plug it. I'm gonna keep the camera on. So to see if anything blown. Let's see. Yeah, 1, 2, 3. No, nothing happened. Okay, let's check the big capacitors. So it's a DC mode. 390 volt, H fixed. H fixed. Yeah, so the 110 volt, let's go to the rectifier bridge, let's go to the capacitor, then from the capacitor, it's go to this transistor for switching, and it's go to step up transistor. The step up, it's gonna get the voltage up from 160 to 400 volt, and that's what we get. So let's put it in the TV and check it. Alright, let's plug it. The main board and T-cone, they are unplugged, and we want to see if the backlight is going to turn on. Yeah, the backlight is on. The backlight is on. Yeah, you can see the backlight, it's on. Here I'm gonna disconnect the power. Yeah, you can see it just go off and on. So now let's plug the main board. Okay, this one and this one. Yeah. The TV is on. I plugged the main port, the TV is on. Alright, we have the picture. Yes. So the TV is fixed. So this all for this video, and see you again.